Mahamanav Aerospace and Research Exploration Private Limited. This is an internship program on avionics presented by Priyanka Ayali. Distance measuring equipment. In this module, we are going to study about the introduction, function, and its uses. Distance measuring equipment DME. It is defined as a combination of ground and airborne equipment which gives a continuous slant range distance from station read out by measuring time lapse of a signal transmitted by the aircraft to the station and responded back. DMEs can also provide ground speed and time to station readout by differentiation. The DME system comprises of UHF L-band transmitter or receiver interrogator in the aircraft and a UHF L-band receiver or transmitter transponder on the ground. Have a look at the figure of distance measuring equipment. Functions of DME. The DME and nav aids function using the different frequencies. DMEs utilize ultra-high frequency UHF whereas the co-located VOR and ILS utilize very high frequency VHF. When an aircraft requests the slant distance, it sends signals called as interrogation pulse to the ground-based DME. The transmitter then responds relaying back a signal to the onboard aircraft equipment. The duration of this UHF signal to and from the DME station is then used to calculate the distance of the straight line from the craft to station. The onboard equipment is used to display the slant distance, can vary from frequency selectors and radio magnetic indicator RMI instrument which display the paired frequently both of DME and VOR ILS or standalone instrument which display information only from the DME. Despite operating in different bands, DME and VOR or ILS frequencies are coupled before the request of the slant distance is made. This is completely manually using onboard equipment and displayed by the VOR or ILS frequency selection. Specifically, DMEs usually operate between 960 to 1215 MHz. DME system work with a certain type of nav aids which include VOR DME, VORTAC and ILS localizer. Because DMEs measure slant distance, any terrain that blocks the line of sight between DME station and the aircraft will impact both the DME's range and ability to communicate with the onboard equipment. Have a look at the figure of the functions of DME. Search mode. 150 interrogation pulse pair per second. The aircraft interrogates the ground transponder with a series of pulse pair and after a precise time delay, typically 50 microseconds, the ground station replies with an identical sequence of pulse pair. The DME receiver in the aircraft searches for a reply pulse pair X mode 12 microsecond spacing with the correct interval and reply pattern original interrogation pattern. Pulse pair that are not coincident with the individual aircraft interrogation pattern, example not synchronous, are referred to as filler pulse pair or squitter. Also replies to the other aircraft that they are therefore non-synchronous also appear as squitter. Track mode. Less than 30 interrogation pulse pair per second as the average number of pulses in search and track is limited to max 30 pulse pair per second. The aircraft interrogator locks onto the DME ground station once it recognizes a particular reply pulse sequence has the same spacing as the original interrogation sequence. Once the receiver is locked, now it has narrower window in which to look for the echoes and can retain the lock. Distance calculation. A radio signal takes approximately 12.36 microseconds to travel 1 nautical mile 1852 meter to the target and back. The time difference between interrogation and reply minus the 50 microsecond ground transponder delay, the pulse width and the reply pulse 12 microsecond in X mode and 30 microsecond in Y mode is measured by the interrogator's timing circuitry and converted to a distance measurement slant range in nautical miles and then displayed on the cockpit DME display. The distance formula, distance equal to rate into time, is used by the DME receiver to calculate its distance from the DME ground station. The rate of the calculation is the velocity of radio pulse, which is the speed of the light rough. By this formula, the time in the calculation is calculated. Specification. A typical DME ground-based responder beacon has a limit of 2700 interrogation per second, pulse pair per second PPS. Thus, it can provide a distance information for up to 100 aircraft at a time of 95% of transmission for aircraft in tracking mode, typically 25 pps, and 5% in search mode, typically 150 pps. Above this limit, the transponder avoids overload by limiting the sensitivity gain of the receiver. Replies to weaker, normally the more distant interrogations are ignored to the lower and transponder load. This was all about the distance measuring equipment. Thank you.